right, guys, this is going to be the recording for Thermal Energy 1.3. So you either doing that on Tuesday or Wednesday, depending on what class hour. And so looking at our module for this week, you guys can dive right on in to the homepage. And remember, everything is linked in that homepage, so you really only need to go here and everything will be there available for you. And so we are focusing on temperature and motion. So what does temperature have to do with energy in the motion of different things, especially molecules? And so down at our agenda, you can see the attendance is here, and then you can see the assignment is linked here too. And remember, you will have an assignment with each lesson, and you'll kind of use it along with the lesson and then try to turn it in at the end of the lesson. And so clicking on that, this will be what pops up. And so you'll see that our warm-up has you using the simulation. And so you're going to want to click on this. That is a hyperlink for the simulation, and we'll open it right back up for you. I'm going to scroll down to my slides down here. And so our warm-up has to do with looking at the simulation and some features that it has. And so there's two things we're going to look at. We're going to look at things it can do in run and things it can do in analyze. And you'll remember all of the Amplify simulations have those two buttons up here in the top corner. Like I said, I will show you here in a second. Excuse my cat who's photo bombing or video bombing. So this video, I'm not going to play it because Screencastify, which is what I'm using to record this, is not good at picking up the sound from videos. But if you would like to watch this, it's going to show you a little bit more about the simulation. And so I'm going to actually open that up. And if you hear weird noises, that's my cat purring on my lap. He seems to want attention right now while I'm right in the middle of this. And so with the simulation, the first thing you're going to notice there is our run and our analyze up here in the corner. And what I want you to do is first start with one thing you can do in the run mode. So that's this one. And the first thing I notice is that I can add a sample. And I have 3 different sizes. I have small, medium, and large. And when I add those in, this pops up and I see all these little blue circles. I can also see that I have pluses and minuses, which I notice is making my temperature go up. I also notice that the minus makes my temperature go down. And I can see these moving. I can see the samples. I can see the energy, the kinetic energy. I can see the energy transfer. If I click these over, I can see the time passing. I can also add samples. So I can add a small sample. I can push them together and see what happens. And then in the analyze mode, which you're going to see is the second question down here. In the analyze mode, I can see my samples. I can view the energy, and you can see it's color coded. Low is like a darker, and then high is like a yellow. And my energy transfer, I can see that the energy is going from A to B. And so those are some features that you can see in the analyze. And you just have to write one, so there's plenty of options for both. And then I'm actually going to go back to the run, and remember this button in the top is my reset. And so I'm going to reset it. Do not close that simulation because you are going to use it. And so going on, you're going to see that we are still using it, and we're going to look at hot and cold water. And if you remember, on Friday, we did a lab demonstration where we had our hot and cold water in our food coloring. And so if you were not here, we did those, and there are videos. Well, I'm not going to go to it because it's going to lock me out of what I'm doing. But there are videos in last week's module of that demonstration if you missed it. But we are going to talk about it a little bit today and kind of tie that in with what we're starting today. I'm actually going to go back to this so I can go to my slides. And so what we did is we had a class discussion and kind of thought about what do we think these small circles in our simulation represented. And so a lot of people said molecule, which is correct. And so those blue circles in our simulation are supposed to be molecules. And so molecules are groups of atoms joined together in a particular way. And so looking at your assignment, you're going to see I put a picture of a water molecule. I swear I can talk. So a water molecule right here, and this is a water molecule because it is arranged in a certain way. So we have 2 hydrogen atoms and 1 oxygen, which is why it's H2O. If it was arranged in any different way, it would no longer be a water molecule. So it has to be arranged in a certain way. And so that definition I just gave you is what you needed to put right here. So I'll flash back to that. And so I was hoping that you would write a group of atoms joined together in a particular way in that definition. So I'm kind of skipping through. And so it's super important to realize that everything is made up of molecules. And so there's obviously a bunch of different types of molecules and atoms, but everything is made up of these. And so that is why we're kind of looking at this in our scenario. And we, like I said on Friday, did our hot and cold water. And so we know that both of our cups of water was made up of water molecules. And we knew that heating them up and having them cold affected those molecules in certain ways. And so we're going to kind of relate that here. And so what we're going to do now is we're going to use the simulation to kind of reference what we did on Friday and kind of get some further explanation. Because Friday was a short day and it was kind of a quick intro. And so today we're going to kind of break it down a little bit further and really dive into what happened with that. And so if you were not here on Friday or you just forget, we had our 2 samples of water. We had one hot and one cold, and we put food coloring in both of them. And then we saw what happened when we did that. And we noticed that the hot food coloring spread a lot quicker. And you can see over here it spread throughout. And then the cold was a lot longer, took a lot longer to spread. And you can see it was kind of stringy and didn't really spread out very well. And so in our simulation, and if you closed it, I hope you didn't, but there's another link to it here. And so we are going to add 2 same size samples. So we're going to look here. We're going to add 2, I'm going to go 2 medium. So it wants us to add 2 same size samples. Done. And then it wants to make 1 sample hot and 1 sample cold. And remember, you use your plus and minus. So to make this one hotter, I'm going to use this plus, and you can see it's adding some heat. I'm going to try to make it as hot as I can. You can see I've maxed it out. And then I'm going to make my other sample cold. And you can see a little ice cube. So I'm going to make it as cold as I can. So that's at 0 degrees. And this is 100 degrees Celsius. And you can already observe some differences. I can see that these molecules are moving a lot faster than these molecules over here. So that tells me that the hotter the substance gets, the faster the molecules move. And then the colder the substance gets, the slower the molecules move. And so looking here, the first thing it wanted you to do is obviously make some observations and then write down here what you notice. And I kind of just told you that. What do you notice about the movement in the hot substance? And what do you notice about the movement in the cold substance? And then down here, you're going to explain what you discovered from that simulation about our food coloring. So when we did it on Friday, why do you think the hot water spread faster when we would put our food coloring in? Why did that food coloring spread? I just can't talk today, can I? Why did that food coloring spread faster in the hot water and slower in the cold water? What did the movement of those molecules have to do with spreading that out? And so that's what I meant by we're kind of connecting the idea. So you're going to write that here. And then down here, we're looking, and this looks similar to what our simulation had. And you can go ahead and close out your simulation if you would like to. We're not really going to use it anymore. But down here, we have A, B, C, and D, and these are showing hot water and cold water. And you can see the key up here is our molecule speed, and so we know the gray or darker color is showing slower, and then the yellow is the faster speed. And so you need to pick which one above shows the difference between the speed of hot and cold. So which one is correct? And so you'll write A, B, C, or D, and then tell me why. This is still adding on to what we just did. And then down here is a quick reading called absolute zero. And it's really interesting because absolute zero is the temperature that is the coldest temperature we've ever reached. And so you can see a picture here. Antarctica is the place where it has been the coldest on Earth. But obviously we have places like space and other places that can get a lot colder. And so it's really short. It's only a couple paragraphs here. But what I would like you to do is while you are reading, I want you to highlight information that you think is important. And so why do you think I would have you read this article? What information do I want you to pull out of it? And so that is what I have you doing. And then I have you doing nothing but highlighting it on here, but, when you go to your exit ticket here, which is your last thing, there is going to be a couple things in there that reference the reading. So you want to make sure you read it so that you could answer those questions on the exit ticket. And I believe that was it for my slides. Sometimes I use all the slides, and sometimes they're kind of just for you to have if you need them. So we know this, but just to kind of close up, when things get hotter, molecules move faster. When things get colder, molecules move slower. So that's kind of the most important thing to understand from today, okay? Other than that, make sure that assignment is done and turned in, and then you have your exit ticket, and that is it for 1.3.